Last but not least, we have the extension step, happening at 72 degrees Celsius. As we can see, our GCT primer is already on our single strand of DNA. Taq polymerase can now bind to our primer and begin reading our piece of DNA. We would like to note that this extension is occurring on both strands of DNA, but we only wanted to show one to hopefully make it easier to pay attention to how the free nucleotides are lining up with their base pairs, G's with C's and A's with T's. And do know that these are hydrogen bonds forming between the base pairs. Notice how the Taq polymerase copied the whole strand of DNA, not just the target piece. We can isolate our target piece of DNA by going through the steps of PCR 2 more times. So here we are again with our double strand of DNA, heating it up to 95 degrees Celsius to have 2 single strands of DNA once again. Once again, labeling them with the correct 5' and 3' ends is important so we know where the primers can attach to. Our system is cooled to 50 degrees Celsius, allowing our GCT primer to anneal. Once again, we are only showing this on a single strand of DNA to allow you to focus on one place, but do know that this is really happening on both strands. Our system can now heat back up to 72 degrees Celsius. Taq polymerase can bind to the primer and bind our free nucleotides to the DNA. Remember that our primer has GCT nucleotides reading in the 5' to 3' direction, so it too will be able to have free nucleotides bind to it. Notice how the Taq polymerase was able to extend our target DNA and leave out the sequences that we don't necessarily want right now located to the right of the primer. Now that the second PCR cycle is complete, we can continue on to the third cycle to see how our target DNA can be isolated and copied over and over again to use towards other biological and forensic applications. Here we have our single strand of DNA after the denaturation step, our primer aligning to the 3' end, and then our Taq polymerase attaching and extending our DNA with those free nucleotides. Now we can see that only our target DNA is available to copy after this third round. From here, our target DNA will be exponentially produced thanks to the repeating denaturing, annealing, and extension steps of PCR.